All right, so let's think through our unit circle, okay, and see what we can come up with when it comes to tangent. All right. The first thing that I'm going to do here is I'm actually going to shift my y-axis a little bit, and because I want to see a little bit on the negative side of this as well. Okay? So we'll put our y-axis here. Okay? Now, let's think through our unit circle, and this will be good practice for us. On the unit circle, how do we get tangent?
Sine over cosine.
Sine over cosine. Okay? Sine over cosine. Now, let's run through some of these, okay? Let's start with 0. What is tangent of 0?
0.
Sine equals 0. Cosine equals 0 over 1 is 0, okay? Now let's try the pi over 4. Okay, pi over 4. What's sine of pi over 4?
Radical 2.
Good, root 2 over 2.
Equals 1.
And cosine is?
Radical 2 over 2.
Root 2 over 2, so tangent equals 1. Alright, so here's 1 at pi over 4. I'm going to get to pi over 2 in just a second, but I want to get one more in here. So let's do pi over 6. Okay? When x is pi over 6, what's sine of pi over 6? No?
No, that's pi over 3. Root 3 over 2.
Root 3 over 2. And cosine is a half. So tangent equals radical 3. Now radical 3 is about 1.7. Alright, so you'll notice this is why I wanted to get this one here, is because notice, unlike sine and cosine, it does not have a max point. Okay? It doesn't have a max point at 1. Now, think about pi over 2. What is sine of pi over 2?
Sine is 0.
1. Okay. Sine is 1.
Cosine's 0. So
Cosine is 0. So what?
It's undefined.
Tangent is undefined. And what'd you say?
Asymptote.
It's an asymptote. It's an asymptote. Okay. Tangent of pi over 2 is 1 over 0. It's undefined. Okay. So we have this asymptote. Now, I want you to think in terms of reference angles and our all students take calculus here. And let's go backwards. All right? If I'm at a negative pi over 4, okay? Obviously that's the same reference angle as pi over 4, but what is tangent in the fourth quadrant?
Negative.
Negative. So where am I?
Negative 1.
-1, okay? I'm at -1, so here's my point. Negative pi over 4, -1. What about a negative pi over... Oh wait, that should be pi over 3. You're saying pi over 3. A negative pi over 3.
1.7. Negative 1.
Yeah, it's going to be a negative 1.7. And then how about a negative pi over 2? It's going to be undefined again, okay? Now, what do functions typically do as they approach an asymptote?
Positive.
What, Eddie?
They get really close to it.
They get really close to it, and as they get really close to it, the value goes up, keeps going up to infinity, all right? So look at this. This is what our tangent function is going to look like, okay? All right? Now, let's keep going a little bit here. Okay? Can we lose the headphones, please? All right, let's say we've got 3 pi over 4. And then we'll go to pi. and then let's see, we'd be at 5 pi over 4, and then 3 pi over 2. Okay, let's keep going that far. This will take us all the way a full 2 pi. We're just starting at negative pi over 2 and ending at 3 pi over 2. Okay? What is tangent at 3 pi over 4? Which quadrant are we in?
Second.
3 pi over 4, we're in the second quadrant, so tangent is...
Positive.
Come on, get
No,
your
third is
brains
negative.
engaged here, okay? You guys have to be able to do this like this, okay? Tangent in the second quadrant is
Negative.
negative. Close your computer and stay with us, please. Alright, so at 3 pi over 4, I have the same reference angle as pi over 4, and I know tangent's negative, so what's the value here?
Yeah.
Negative 1, okay? Negative 1, okay? What's the value at pi? 0. How about 5 pi over 4?
1.
1. Okay, so look at what's going to happen. Alright? 3 pi over 2 tangent is?
Probably undefined.
Probably undefined. It is undefined, yeah. Okay? So look, we got another repetition here of that same thing we saw there. Okay? And this is going to repeat like this. Okay? And what does this make our period? How often is it repeating? Not every
Pi.
quadrant.
Every pi.
Every
Pi over
pi,
2.
every 2 quadrants. Okay? Notice here what we've got. We've got the 4th quadrant here. Okay, 4th quadrant right here. Then from the y-axis to this asymptote is the 1st quadrant, right? From pi over 2 to pi, you guys know that's the 2nd quadrant. And then from here to the next asymptote is the 3rd quadrant. And you guys can see the all students take calculus, right? It's positive in the 1st and 3rd quadrants. It's negative in the 2nd and 4th quadrants. Okay? The difference in this case, as opposed to sine and cosine, is that it's repeating every pi instead of every 2 pi. Okay? Now, notice how we're approaching infinity and negative infinity. We don't talk about amplitude in relation to tangent,
So
okay?
There's no amplitude.
Yeah, this isn't one that has an amplitude because it's infinite. The range is all real numbers. Okay? The domain, and also identifying our asymptotes here, okay? We could say that our asymptotes occur where x equals x equals what?
Pi over 2.
At pi over 2?
3 pi over 2. Negative pi over 2.
Okay.
So every pi over. So every quarter?
Every pi away from pi over 2, right? So we could say it like this. We could say pi over 2 plus, we'll just use n pi. Okay? And we'll then say that n is an element of the integers. And remember, integers, the symbol for that is the z with the 2 little bars across. Okay? N is an integer. Alright, so that covers the ones going in the negative direction and positive direction. Okay? So there's our tangent. There's our
So that
tangent.
would be the domain is that x equals pi over 2 plus n pi, where n is not integers.
The asymptotes are these.
Right.
The domain is all real numbers except for when x is these. Yeah. Now, our cosecant, secant, and cotangent are just reciprocals, right? They're just reciprocals. So if you think about this, okay, everywhere I have an asymptote, what will cotangent be? What's the reciprocal of something undefined?
0.
0. It's defined, it's 0. Instead of 1 over 0, now it'll be 0 over 1. So all of these asymptotes will be zeros of the cotangent function. What will all the zeros of tangent turn out to be for cotangent? Those will be undefined. Those will be asymptotes, okay?
Yes.
So, yeah, it shifts, okay? It shifts. We'll do this one down here. Cosine, or I'm sorry, cotangent of x. 0 was a 0 of tangent, so now we have an asymptote, okay? The pi over 2 was an asymptote, so now it's a 0 for cotangent. Pi was a 0, or I'm sorry, was an yeah, it was a 0 for tangent, so now it's what for cotangent? It's undefined. It's an asymptote, okay? And then we have 3 pi over 2, which is going to be a 0, and then we have 2 pi, which is again going to be an asymptote. All right?
It's just a bunch of. What is it? How would you graph that?
Well, here's the thing. It's going to have a similar shape, but let's think in terms of our quadrants and what the values of what the signs of cotangent are going to be. In the first quadrant, between 0 and pi over 2, cotangent is positive. Between pi over 2 and pi, that's the second quadrant, right? So cotangent is negative. So watch this. It's going to do this. We're going to approach the asymptote, go down through the 0, and then approach negative infinity as we get closer to pi. Okay? See how this is kind of intuitive if you keep in mind what we know about trig.
This would be the same thing.
And then we're going to repeat the same thing. Now we're in the third quadrant, so it's going to be positive. We hit the 0, then we're in the fourth quadrant, tangent's negative again. Okay? Or I'm sorry, and also cotangent is negative again. Okay? So there's our cotangent graph. Okay? So a similar shape here. However, I'll show you kind of the finished product here. And you can see them side by side. This one is going to be increasing. This one is going to be decreasing. And also, the asymptotes are all shifted over pi over 2. Okay? Now, notice here also the domain and our asymptotes. Instead of it being pi over 2 plus n pi, it's just n pi. The domain is all real numbers except for multiples of pi, because those are the vertical asymptotes. X equals n pi.
How would you say it shifted by?
Well, it shifts over. Notice here it was at pi over 2, now it's at pi. So it shifted over pi over 2. By the way, what does that bring our memory back to? Cotangent and tangent with a pi over 2.
Sine and cos shift over.
Sine and cosine had a pi over 2 that was shifted over. So do secant and cosecant. What identities were those?
Cofunction.
The cofunction identities, okay? Those are our cofunction identities. This is, here we can see that take place, okay? So. All right. Now, let's think about sine with cosecant, all right? Sine with cosecant. I'm going to draw the sine curve real quickly here. We're at 0, and then at pi over 2, we're up here at 1, right? Let me make that a little lower. 1. And then at pi, we're back to 0. And at 3 pi over 2, we're at -1. And then at 2 pi, we're back up to 0. So here's our sine curve. You guys should be able to sketch that. Just a normal sine curve. That should be a no-brainer at this point. Okay. So now let's think about cosecant. Cosecant is the reciprocal of sine, right? So let's think about it. If I start taking reciprocals, what am I going to get?
I know what the graph looks like, but I can't really explain.
Okay. Can someone
Cosecant
explain?
of 0b.
Okay, anywhere sine is 0,
It's undefined.
cosecant is undefined, right? Because you take the reciprocal of 0, it's undefined. So check this out. We have more asymptotes.
Lovely.
Okay? All of these locations give us asymptotes. Okay?
And where the curves in each of the asymptotes are just flipped over and then they
Okay.
It's like a parabola.
It kind of looks like a parabola inside, but it approaches an asymptote. Okay. There is a specific point, though, that we can get here. What's the reciprocal of 1?
Well,
Just
1. So check this out. Here, what we're going to have is it's approaching this asymptote from the inside, going up. Okay? And notice cosecant is positive, the same two quadrants that sine is positive. Okay? If I keep going down here, what's the reciprocal of -1?
just
-1. Okay? So, here I'm going to be approaching my two asymptotes. Okay? But it's going to be going down. So the blue here is one period of the cosecant function. Okay? Now again, we won't talk about amplitude because it goes infinitely. Alright? We don't talk about amplitude, but we do talk about the period. The period would be 2 pi again. Okay? Because once we get over to, if we go further to the right, we're going to have another value of 1 here. There's going to be more asymptotes.
can we call them parabolas, or is it not like?
No, because remember,
Equation.
parabolas continue to go out. Parabolas have a range that's all real numbers.
Okay.
I'm sorry, a domain that's all
Domain,
real
sorry,
numbers. So yeah, they kind of look like parabolas, but they're approaching an asymptote as opposed to continually
Yeah.
widening. So I would avoid. All right. So there is our cosecant, and then for secant, I need to move some stuff down here a little bit. Okay. For secant, secant's the reciprocal of
Cosine.
cosine. All right. So if I sketch the cosine real fast here, cosine starts at the top and it ends at the top at 2 pi. At pi, we're at -1, and that means at pi over 2, we're at 0, and at 3 pi over 2, we're at 0. Here's my cosine curve. All right. Same principle applies here as what we just saw with cosecant. Okay? The reciprocal of 1 is 1, and anywhere we had a 0 is now an asymptote. Okay? And this is where it might be helpful to, give ourselves more than just this first period of cosine. Okay? I should actually put points, that'll help. Okay. So here. Okay, so for cosecant, I'm going to have asymptotes there, 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 there. Okay. Anywhere I'm at a max or min point, my secant is going to hit that as well, because the reciprocal of 1 is just 1. The reciprocal of -1 is just -1. Okay. And here we have our secant curve. Okay. Now, I am not going to ask you to sketch transformations of these or anything like that, but I do want you to be able to recognize, tangent, cotangent, secant, cosecant, if you saw them. Okay? And just so you can see those again, kind of side by side. Notice the period is still 2 pi. However, our domain, and we have some asymptotes here that you can see. Notice the asymptote for cosecant is actually the same as cotangent. The asymptotes for secant are the same as for tangent, which if you think about it makes sense, because in cotangent you have cosine divided by sine. Cosecant, you have 1 divided by sine, so it's going to be undefined the same time that cotangent is. Secant's 1 over cosine, tangent sine over cosine, those are going to be undefined at the same times. Okay? So a lot of connections to make here. Alright, so any questions, comments, anything? Alright. I gave you a little bit of practice with these that you can work your way through. So take some time, look at it. And on Thursday, we're going to really focus in on getting models. Okay? Thursday and Friday. Friday we'll do more models and also review. And we're going to have our test a week from today. Okay?